Hello, my name is Robert Behrens. This is Fluent project number 2 for Dr. Osbey's Fluids class. So we're doing the 0 degree, the 30 degree, the 60 degree, and the 90 degree flat plate simulation. Right now I'm just going to be doing the 30 degree. So I'm going to drag Fluent out. I'm going to start by right clicking geometry and doing new design model or geometry. Okay, so we'll go to our axis, set it up. Now we want to set our units to centimeters. We're just going to draw a horizontal line. Doesn't really matter where, but we just need a reference line to get our angle from. This is going to be the bottom of our flat plate that we're drawing right now. Now we'll go to dimensions, angle, get the angle between these two. I don't know why it does that. Okay. So set this to 30. Now we're just going to draw the rest of our flat plate. Okay. Now we're going to clean this up by trimming it. And we're going to give it dimensions. So this is going to be 0.1 centimeter. This will be 30 centimeters. Okay. Now what we want to do is create a really big rectangle around this for our fluid to flow in. And I'm going to give this dimensions just to make it easier. You don't need to give it dimensions, but I like to make this 250. I'm going to make it 300. We really want to see what's going on behind this too, how the fluid flows, so it's good to have a longer tail end. I'm going to make this 120. Then I'm just going to orient this better around my flat plate by changing the distance from the axis. So I want this to be 40. I want this one to be about 55, maybe more than that. So let's try 70. That's about right. So we want this to be pretty centered. Okay, so I'm just going to get rid of these dimensions because we don't really need them. And then we're going to go to concept, surfaces from sketches, apply that, and generate. Now if we did this right, yep, should have a little flat plate hole there. So go back to our workbench, go to mesh. Hopefully this will load soon. There we go. Okay, it brought me back to my design modeler. Okay, here we are, mesh. So we want to insert a method, and we want to select our geometry. Quadrilateral dominant, that's what we want for method. We can generate a really big mesh. So what we're going to want to do is I want to set this to 0.02 for element size. That's what I like. I think that works pretty good. If you have a mesh too low, when you try and initialize in your setup menu, it'll just give you an error. It'll still work, but it'll give you an error and tell you that it's not going to converge. So we're going to insert refinement because we want a little finer mesh. Choose our geometry. We're going to do max refinement of 3. We can generate. Okay, so back to our mesh. So I had to restart the meshing. For some reason, it was being weird. The meshing for this project has been like really weird for me. I'm not sure what it is, but I've been working on this project for a lot more time than it should really take, and the meshing has just been super weird. So keep that in mind. But we have, I'm going to be naming my edges now. So I edge selected and then I pressed N on this, or I clicked this edge and pressed N. So this is our inlet. But yeah, if you're watching this video and you're doing this project later, like semesters after mine or whatever, just keep in mind that this project's been a little weird. Like I've done these experiments so many times over the past few days, and it's just given me weird results each time. I've even had to like start Workbench over again. Like this Workbench is empty, but I have a different Workbench with all of these, like the 0, 30, 60, 90, and for some reason when I was trying to do one of them, it was coming out weird, so I opened a new Workbench and did it, and it worked fine. So just keep that in mind. This is gonna be our bottom wall. Our top wall. I'll call this upper wall. So just keep in mind that this project's kind of weird. Front wall. And there is a different method of doing this project that seems to work for a lot of people, and I've just been working on this one. I started this project pretty early, so I'm already kind of in too deep with this method, so I'm just trying to stick with it and get it done. But now we're going to go back to our Workbench and update our mesh. Now we'll go to Setup. We want double precision and 4 solver processes. You can do 1 solver process, but 4 is going to make this work faster. Okay, everything's imported. We can see our inlet, outlet labeled already. So now we're going to want to go to models, viscous. We want K epsilon, enhanced wall treatment, and under enhanced wall treatment options, we want pressure gradient effects. OK on that. Then we go to materials, air. We want this to be 1.2 for my project at least. Numbers may change in later semesters. So we're going to change / create. Go to cell zone conditions. Make sure this is air. We're going to apply. Boundary conditions. Go to our inlet. And for this project, it's 15 meters per second. That's our magnitude. We just want to make sure that all of these are correct. So wall, symmetry. We're looking down here at type pressure outlet. Yep, looks right. So everything else looks pretty good. Now we can go to reference values. We need to change this from inlet, surface body. The length, remember our flat plate is 30 centimeters. And that's going to be the area with our 0.1 centimeter width. And everything else here is correct. Let's go to initialization. I don't want to initialize. So yeah, if you have too coarse of a mesh, you'll get a message down here that's in red that says warning. Did not what's the word? I'm looking for a word while also trying to do this, which makes it hard. But anyways, you'll get a warning down here. So just know that you need better mesh or more of a fine mesh, and you can go back and change that. So a number of iterations will do 1,000. Probably not going to need 1,000. Oh, so it's going to say mesh did not converge in a certain number of intervals or something like that. And what we're looking for right now is convergence as well. So it shouldn't take 1,000 to converge. It should converge earlier, and it should tell us that. And it can range from like 40 iterations to 500. I've had it do 500 and still converge. But right now it's looking pretty good for convergence. Okay, cool. So converged in 65 iterations, which is pretty good. So for this project, we want to go to reports and forces, select all our walls, and we can just print. And then you can move this around if you need to. Oops. Did not mean to do that. Oh, I messed this up. Okay. Yeah, so not exactly sure where that went. There it is. But yeah, you can just move this wherever you want. This is, geez, I'm really messing this up. The stuff you need is down at the bottom. All from here. So I'm just gonna put that back over there and not worry about it right now. And then also, what you can do is you can go to plots, XY plot. What you're gonna want to do is you're gonna want to do wall fluxes for y-axis function, x wall shear stress, and then for x-axis curve length, we're gonna do the upper wall. Save and plot. Okay, that's good. So not just me, but other people also had the problem where like it wouldn't plot the upper wall for some reason. It just gave you an error. I had that problem with this the last time I tried the 30 degree, which I recorded it, and this is why I'm re-recording it. But even one of the tutorials Dr. Osbe posted from YouTube, that one of the guys had that problem. So just be aware of that. So now we can go to results tab. Let that load up. So we'll get some nice contours and work our way around that to see some results from there. I'm gonna fix this while this loads. Maybe not. Okay. So here we are. We can add some contours. We want symmetry 1. We can try velocity first. That gives us a pretty good picture. We can apply. So this is pretty much how it should look. I've had it give me like a weird hurricane behind the plate for some reason, and there was no velocity even coming out of the inlet. Not sure what was with that, but like I said, that was in the workbench with the others, and I opened a new workbench like I did here, and that fixed it. So maybe there's something weird with the cache. I'm not sure, but I've been having a lot of problems with this project and just weird stuff like that happening. So we can also add some vectors, which are pretty cool. Give it a factor of 3. Give us a pretty good view of them. I personally prefer the 2D arrow. We just leave that symbol size at 1. Oh. Need to add a location of symmetry 1. Get rid of our contours. These are pretty bunched up. So I'm just going to put this size down to 0.5. Yeah, so we get a pretty good view of that, how the air flows around it. I like the vector view. I think it's pretty cool. We can also go back to contours, see pressure. It's pretty cool as well. And Dr. Osbey also in his video showed turbulence kinetic energy. Something that I was just kind of playing around with on my own was streamline, which I think is pretty cool. So just start this from the inlet. And we could do 50 points. And this will also show us how our air flows. I really like this. I think this is pretty cool. Yeah, okay. I think this is pretty cool. Kind of like vectors, but not, less busy, I guess, is a good way to put it. How the air flows. But while we're here, what we can do to get some more data from our plot here, I'm going to set this back to velocity. I don't really think that matters, but we can go to tools. We can actually put a probe here. And let's say we want to probe it like here. We want to get information from here. All right, so there's our probe, this little gray dot. Right now we have pressure, so very low pressure. And like if we look over here, very high pressure. We can also look at wall shear, which is something we do want to look at actually for our project. But yeah, so you can do that. And then the last way of exporting data or getting your data is you can go to export. So you can choose upper wall, which is of course going to be this one, and then wall shear X. And that's going to be the Excel file that you're going to get from that, and just put it anywhere. Okay, so that is all of Project 2. Thank you for watching.